We live our everyday life looking at thousands of things. Most of them we forget, since our brain deems them unimportant enough to remember. When we pass a street, we don't remember everyone's outfit, their blinking patterns, the color of their cars, or which buildings had their lights on. To the untrained eye, these are all noise. Have you ever thought if any of these could have meanings? No, I'm not talking about the meaning of life here. And I'm not saying that everything has a pattern. Most things that we pass by every day are actually random noise. Within this randomness, there may be a pattern that is only visible if you are paying attention. Spies have mastered the art of hiding in plain sight. A bench with spilled coffee on it may well be only a bench with coffee spilled on it, but it could also carry a special kind of signal for a person that is looking for it. The same way an image on your phone could be used to hold information disguised as noise. There is a technique called Image Steganography, which hides data in images without making them larger or weird in any way. Our brain is trained to ignore noise and pay attention to the image. Maybe sometimes you have to ignore the image and pay attention to the noise. Hello Internet, I'm Arya Bagari and today I'll explain a technique called Image Steganography, how it works, why it's a double-edged sword, how it is used for evil, and how you can and should use it for good. So what is image noise? Basically, the beautiful colors that you see in an image are slightly different. I mean less than 0.5% different. Unless we get really close, we would not be able to see the difference. Cameras, same as our eyes, actually perceive these small differences. That's why when you paint something in Photoshop, it does not look realistic unless you actually add this noise. In video games, this noise is also added to make the game more realistic. What I'm calling noise here is also called the texture in some cases. So we already know these inconsistencies exist in images. Next step would be to control it to carry a message. Think of a flickering light bulb. It flickers randomly, but if you control the randomness, you can send data using Morse code. The same way, if we control this noise, we can use it to carry data. This sounds great, but how are we gonna use noise to carry data? So first, we have to remove some data, preferably in the noise. This way, the difference will be invisible and will make room for our secret data. I'll exaggerate the effect by removing lots of data so you can see what happens when we try to fit too much data into an image. Every image is made up by multiple pixels. Each pixel holds a single color, nothing more. And once placed right next to each other, they form pictures. Like how pieces of a puzzle don't really look like anything, but once you put them together, you can see the bigger picture. Our monitors work this way, but how are we actually producing these colors? We simply use 3 LEDs that are red, green, and blue close to each other. So when our eyes are far enough from the screen, we do not see these as separate, but we see them as one light source. When we combine them, we get the color white. We get black when we turn all the lights off. We get white when we turn all of them on. And red, green, and blue when we turn only one of these LEDs on. Other colors can be made with combinations of these 3 light sources. So a picture is actually made up of 3 pictures, each captured in one color. These sub-pictures are also called color channels. So when we refer to the red channel, we refer to the picture that only contains the red color values. These color channels would look something like this. As you can see, the area with most reds will be brighter in the red channel than the blue and green channels. Now going back to image steganography, these color channels can each hold a different file, or one file at the same time. So what we do is make all of these numbers even by removing one from the odd ones. So 255 turns to 254. And 1 turns into 0. You get the idea. So now we have to convert our private data to binary values. Then we go over the image pixel by pixel. Let's go over a quick example. We have a couple of pixels to work with. First step is to make them all even. Awesome. Now it's time for the next step, which is adding our super secret data. So our first bit is 0, so it doesn't change the first pixel. Our second bit is 1, so we add 1 to 252 and get 253. We do the same for the rest, and now our image is ready. This technique has one major flaw though, which is also one of its greatest security measures that you cannot find in any other technique. These images need to be intact for us to be able to read the message behind them. Many social media platforms use compression to lower image quality slightly to make it easier to send. This compression is usually not that visible to the human eye, but it does make the image significantly smaller. So if you have an image with, let's say, your password inside, whoever sends it through one of these platforms automatically destroys the data within it, which is super cool. Another major flaw for this technique is that if the original image is available, it is super easy to decrypt in most cases. I do have a technique that would fix this problem, but I'll share that in one of the future videos in this series. Now that you know how it works, it's time to discuss who would actually use this technique. There are rumors that many spies and criminals use this technique to hide really important stuff. But we are not focusing on that application of this technique. What we are focusing on is the good that this technique could bring the average customer. Without going into too much detail, a project that I'm currently working on will make the average Joe that has no knowledge of software whatsoever able to hide his passwords and diary within his image gallery. So the diary is hiding in plain sight. You can't crack open a lock you don't know is there. The pictures still look normal, but they hold your most precious data safe. For big companies, they can use this technique to find leaks in their company data. So let's say if Netflix was to use this technique, they would put the person's username in the video when the video leaves the servers. Then, if they see their movies leaked on the web, they know who exactly put it there, and their lawyers would take care of the rest. So this is it for this video. I hope you enjoyed it. You made it to the end of this video, which means you probably like to know more. If that's the case, like this video, subscribe, and turn on the notification bell so you'll know when the next video in this series hits the web. As always, everything I mentioned above will be linked below the like button. I put many resources like this on my YouTube channel and my personal website, so definitely take advantage of those resources. So until next time, stay paranoid, stay alive.